Okay, so today we're going to talk about the counting principles for probability. Okay, so yesterday we talked about sample space and what that means for us, and we saw just like a general overview of new vocabulary for the unit. So now we're going to dive a little bit deeper into some of this vocabulary. So the first thing we're going to talk about today is a permutation. Okay, a permutation is an arrangement of objects in which order is important. Okay, so the order matters here. The number of permutations of R objects taken from a group of n distinct objects is denoted by this formula right here. Okay, now let's talk more specifically about what all the parts and pieces of this formula actually means. So the capital P stands for permutation. Okay, then the n variable stands for, like, I like to think of it as your total amount. Okay, whether we're talking about the total number of objects, trials, items, it's just like your total number that you're trying to obtain. Okay, then the R represents the actual. Okay, so the actual number of objects, trials, items that you obtain. Okay, so on example 1, they want us to find the number of permutations. So what they're wanting us to do is to utilize this formula up here to find the number of permutations needed. Okay, well, looking at our template, our formula here, and our setup here, then we can say that our n is 5 and our r is 3. Okay, again, all I'm doing is utilizing this template set up by the formula and then breaking apart and labeling for myself what everything is. Okay, then I'm going to plug these values for n and r into this formula. So I will have 5 factorials, remember we learned about that yesterday, over, in parentheses, 5 minus 3 factorials. Okay, now again, all I'm doing is taking these parts and pieces and dropping them in where they go into this formula. Okay, then we can utilize our calculator like we did yesterday, typing in those factorials. Okay, and when we do that, please make sure that you're typing in the denominator inside parentheses because it will make a difference with our answer. When you hit enter, you should be getting 60. Okay, looking at B, same thing. Our n is 4, our r is 1. So when I plug them into the formula, I will have 4 factorials over, in parentheses, 4 minus 1 factorials. Okay, now remember, to get to that factorial button, if you need a review, you're going to press math, arrow over to the probability, and then option number 4 is that factorial. Again, it's not an exclamation point, it is a factorial. Okay, when you do that, you should be getting 4 as your answer. Okay, rolling into example 2, it says you have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. How many arrangements can you complete 4 of the 6 assignments? Okay, so first of all, we need to identify our variables. We need to figure out what is our n value and what is our r value. That is our first goal, is to figure out those. Okay, so remember, up above, we talked about how our n represents our total number of objects, trials, or items, and r is the actual that we obtain. So the actual number of trials, objects, items that we obtain. Okay, so first of all, how many total homework assignments do we need to complete? Hopefully you're telling me 6. I have 6 total homework assignments that need to be done. So that's my n. Okay, now how many can you likely complete? Like, what is the actual number that you can complete? 4. The actual number of homework assignments that we can complete is 4. So again, here's my total, and then the actual that I can get done. Okay, so now I have 2 options. I could utilize this permutation formula up above, or I can learn to use my calculator in another way. So first of all, let's set ourselves up. We're talking about a permutation, so capital P. Again, I'm really just utilizing this formula, this setup up here. Okay, our N value goes first, and so we said that was 6. Okay, then our R value goes second, so we said that was 4. Okay, now again, kind of like we did on example 1, A and B, I can drop these into the formula, so 6 factorial over, in parentheses, 6 minus 4 factorials. So I could type all that in, or you can just type in this much of it into the calculator and let the calculator do the rest of the work. So let's talk about how to do that. To type in just the first piece of this, we're first going to press the number 6 in our calculator. Okay, after we press the number 6, we're then going to press that math button again. So I'm kind of guiding you through how to use the calculator. So punch the number 6, then the math button. Then you're going to arrow over to the probability feature. Okay, and then you're going to select this time option number 2. Okay, and you'll notice when you do that, it pops up with that NPR. Okay, it pops up with that formula in it. Okay, then you're going to punch the number 4 and then enter. Okay, when you do that, your calculator is doing all of this for you. It's doing that for you rather than you typing it in. So when you do that, you should be getting 360 arrangements. Okay, let's look at example 3 here. It says you were left a list of 9 chores to complete. And how many arrangements can you complete 5 of those chores? Okay, so let's start out identifying our N and our R. So how many total chores were you left? 9. How many actual chores do you need to complete? 5. Okay, so let's put them in our setup. Capital P for permutation. N first, R second. Okay, and don't need to necessarily mess with all of this. Instead, I'm just going to utilize this new calculator feature that I learned, and I'm just going to type this all in. So we're going to start with 9, then math, PRB, option 2, then our R value is 5, and then enter. We should be getting out 15,120 arrangements. That is our answer here. Okay, continuing on. Now let's talk about permutations with repetition. So permutations can repeat or they can essentially not repeat. We have 2 different options here. So now we're going to talk about what happens when things do repeat. Okay, so the number of distinguishable permutations of n objects where one object is repeated a certain number of times and another is repeated a certain number of times and so on, we utilize this formula right here. Okay, so I know that looks like a lot, so let's break it down. So n, we already talked about, is our total. It's our total number of objects, trials, or items. Okay, now let's talk about what this S1, S2, and SK mean. Okay, so S1 is the number of times that one specific item repeats. So number of times one item repeats. Okay, so then S2 would be the number of times a second item would repeat. Okay, so then SK, that's representing as many items as possible repeating. Okay, so let's take a look at example 4 here to really understand what all of these variables mean in this formula. So it says find the number of distinguishable permutations of the letters in first Mississippi. Okay, so let's start with our variables. We have we have N, S1, S2, and possibly SK. That's a maybe. Okay, so N is the total. Okay, how many total letters are in the word Mississippi? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 total letters in the word Mississippi. Okay, now, excuse me, our S's represent letters that repeat themselves. Okay, so let's look at I first. So how many times does the letter I repeat itself? 1, 2, 3, 4. So my S1, which represents the letter I repeats itself 4 times. Okay, well, what's a second letter that repeats itself? Okay, well, the letter S repeats itself as well. So S repeats itself 1, 2, 3, 4 times again. Okay, do we have another letter that repeats itself? Okay, so we can change that K to a 3. We have a third letter that repeats, and it's P. Okay, and P repeats itself once and twice. Okay, so that's how we identify all of these variables. Now all I need to do is take these variables and drop them in where they go into this formula. Okay, so this formula says we have n factorial on top, so our n is 11, so 11 factorial, over, we start with S1. S1 was the number of i's, so 4 factorial, times S2, which was the number of s's, which again was 4 factorials, okay, times the number of p's that are in Mississippi, which is 2 factorials. Okay, so that's how we utilize this formula. Now, again, you're using your calculator to do this problem for you using that probability feature. Please make sure, though, that your denominator is inside parentheses because it will make a difference in your answer. So when you type all of this in, hit enter, you should be getting 34,650 permutations. Okay, let's look at B. Okay, again, they're asking us to find the number of distinguishable permutations in the letters now in the word California. So let's start with N. How many total letters are in the word California? Okay, I got 10. Okay, now we're looking for those S's. I'm going to just write down 2 for now. So we're looking for letters that repeat themselves. So C doesn't repeat itself, so A's next. A repeats itself twice. So the letter A repeats itself twice. Okay, so now we're done with the A's. L doesn't repeat itself. Next, I. I repeats itself, again, twice. Okay, F doesn't repeat, O doesn't, R doesn't, and N doesn't. So we only had 2 letters this time that repeated themselves. So now utilizing that formula, our N goes on top, so we will have 10 factorials over our S1 was 2 factorials times our S2 was again 2 factorials. So once again, please make sure you put your denominator inside parentheses when you're typing it in. And I got 907,200 permutations. Okay, moving right along, let's look at example 5 now. Okay, so on example 5, it says, what is the probability that a randomly selected permutation of letters would spell the word Mississippi? Okay, so we're kind of going back to what we talked about yesterday when it comes to probability. Yesterday, I broke down that I think of probability as our chance of something happening over our total option. Okay, so our chance of all of these letters spelling the word Mississippi is 1. I have 1 chance that that will happen the first time. Okay, now out of all of the different options that we had, let's look back at our permutations from that last problem. All of the options, total options that it would spell the correct thing, are what we just calculated. So that would be our 34,650. That's how many different options we have. Okay, so if we type that into the calculator, 1 divided by 34,650, I just want us to get like a concept of percentage there. Okay, it is going to end up being 0.003%. So less than 1% chance that those letters would spell Mississippi the first time. Okay, moving along, let's talk about combinations now. So we talked about permutations, now we're going to talk about a combination. Okay, combination is a selection of R objects from a group of N objects where the order is not important. Okay, so our order is not important. Okay, remember, we already talked about these variables. We said that R was our actual number of objects, items, trials, and N was our total number of items, objects, or trials. Okay, so to find or to calculate combinations, we have a formula for it as well. Looks very similar to permutations with a few added things in here. So on example 7, they want us to find the number of combinations. Okay, so again, kind of like we did for permutations, let's identify our N and our R. So our N is going to be 7, our R is 4. Okay, and then I'm going to take those variables and I'm going to substitute, I'm going to replace them where they belong in this formula. So we will have 7 factorial over, in parentheses, 7 minus 4 factorial times 4 factorials. So I'm just plugging in N and R where they go. Okay, when we type that into the calculator, we should be getting 35 combinations. So 35 combos. Okay, now I want to take a look at how we would do this utilizing our calculator rather than this formula. Okay, so we're kind of going to go through the same process that we did in our calculator for permutations. So I'm going to start by typing in, for this example, the number 6. Okay, then math. Then PRB for that probability feature. And then this time option number 3 for our combinations. Okay, then I'm going to type in the number 3, and then I'm going to press enter. Okay, and when we do that, our calculator should be giving us 20 combinations, so 20 combos. Okay, let's look at an example here. So question number 8 says you are picking 7 books from a stack of 32. If the order of the books you choose is not important, how many different 7-book groups are possible? Okay, so kind of like we did for permutations, let's start out by identifying our N and our R. Okay, so remember, N is the total. So how many total stacks of books do we have? 32. Okay, R is the actual, okay, our actual number. The actual number of books that we are picking is 7. Okay, so we're doing a combination, so capital C. Our N value goes first, so 32, and our R value goes second, so 7. Okay, now we're going to utilize our calculator to do this. So when we type this in, this time our N value is 32, then we'll press math, arrow over to PRB. We need option 3 this time. Then we're going to type in our R value of 7, and then hit enter. When we do that, our calculator gives us, let's see here, 3,365,856 combos. Okay. Example 9 says a community center hosts a talent contest for local musicians. On a given evening, 7 musicians are scheduled to perform. You are friends with 4 of the musicians. If the musicians are randomly selected to perform, how many different orders can your friends play in? Okay, starting out with N and R. So how many total musicians are there? There are 7. Okay, how many of them do you actually know? 4. So we're finding a combination. So N first, R second. Okay, go ahead and punch that into the calculator. And we should be getting 35 combos. Okay, last couple questions here. They want us to identify whether you would use a combination or a permutation in order to solve the following. Okay, well, we have to fully understand the difference between a combination and a permutation. So a combination, our order of events does not matter. Whereas a permutation, the order does matter. Okay, so looking at example 10, it says 8 teams are competing in a basketball tournament. The top 3 teams earn medals. What would you use to determine how many different ways there are to medal? Okay, so if we're talking about teams earning a specific medal, then our order of events does matter. Our order does matter, so we should be choosing permutation. Okay, example 11. If you are randomly placing 24 pictures in a photo album and you can only place 4 photos on the first page, what would you use to determine how many groups of 4 pictures are possible? Okay, well, they gave us a very good keyword at the beginning. You are randomly placing these 24 pictures. So if we're randomly placing them, then our order of pictures does not matter. So we should be choosing a combination.